Right. So first question, this looks like testing our knowledge on isosceles triangles. It says AB is equal to BC. So I would encourage you again to mark up your test just so you don't get confused and think it's these two that are congruent. Okay, so if those two are equal, all I need to do is set those two side lengths equal to each other and solve for x. Okay, so I've answered part of the problem. First part said find x. Then it wants me to find the legs of the triangle. So I'm just going to plug 5 back in here. 25 plus 5 is 30. This side better be 30, or I did something wrong because it's isosceles. 2 times 5 is 10 plus 20 is 30. 9 times 5 is 45, minus 5 is 40. So the three lengths are 30, 30, and 40. Find the measure of the sides of the triangle if the vertices are 1, 4, 5, 1, 2, negative 3. How do I find the lengths when I'm given points like that? Nobody knows? Distance formula? Yep. And if you don't remember the distance formula, it is up there. But if you'd rather not use a formula, remember you can just kind of make each one of these a right triangle to get from this point to this point. This distance is 1. This distance is 1, 2, 3, 4, 5, 6. So this line is the hypotenuse of the right triangle. This squared plus this squared has to equal this squared. Okay, this squared is 36, plus 1 is 37, so this must be the square root of 37. It's a cleaner way to do it, but if that just confused you, then use the distance formula, plug it in, and you'll get the same answer. So one of the sides is the square root of 37. Let's draw another right triangle. What is this distance here? From here to here. 3? And how about from here to here? 3. So if this is a right triangle, what's the hypotenuse? What's the formula for a right triangle? Pythagorean's theorem. A squared plus b squared equals c squared. So a squared is 3, 3 squared is 9, plus b squared is 9, equals what I'm looking for, c squared. So c squared must be 18. C is equal to the square root of 18. Not going to worry about working on simplifying a radical yet. We'll worry about that in chapter 8. So square root of 18 is fine at this point as an answer. Do you want me to do it plugging it into the formula? Which way do you guys prefer doing it? Finding the...
You put g at 2, negative 2.
Huh. Thank you. 2, negative 3 changes that up a bit. So now my triangle is 3, 4. Same thing, 9 plus 16 square root is 5. This one will change too. It should be 7 and 1, which makes it the square root of 50. Sorry about that. Okay, this one, make a right triangle. What's this distance? 3. What's this distance? 4. Since you don't know special triangles yet, I can tell you this is 5 because the 3, 4, 5 is a special right triangle. You know it. You may know it. But if you don't know it, Pythagorean's theorem, square 3, square 4, that's equal to c squared. So c is equal to the square root of, 16. C is equal to the square root of 25, which is 5. So it should be 5, 5, square root of 50. Okay? If you don't know how to use the distance formula and you know that's going to be a problem on the test, I would encourage you to practice it tonight. Okay, either using the triangle method like I did or just the distance formula. The distance formula will be up there tomorrow, so you can refer to that if you need to. I think the triangle method's a little easier, but especially when you get to the ACT, so you don't have to memorize the distance formula. Okay, use the figure below to answer the following questions. Anytime they give you two parallel lines, which are what these arrows mean, you're probably going to use that piece of information to find one of the angles. They normally don't just give that to you if it's not something they want you to use. So if I look at those two lines and I redraw them with a transversal, and this is 70, and I'm trying to find this one, what is that called? What kind of angle? Alternate interior, alternate exterior. What's the name of that pair, that angle pair with parallel lines? We did it last chapter. What's that? Alternate interior, that would be right here. What is it when they're here and here? Corresponding. Okay. Corresponding angles are equal, so I know right away angle 2 is 70. Angle 1 and 70 degrees form a linear pair, so angle 1 must be 110. And then in this triangle, all three angles must equal 180. I know this is 70, this is 80, that's 150, which means this must be 30. Identify the congruent triangles and name their corresponding congruent angles. So I'm going to just use whatever order I want for the first one, and then I've got to make sure I write the second one in the right order. So congruent to A is F. Congruent to B is D, and congruent to C is E. Then it wants me to name the corresponding angles. So angle A is congruent to angle F, angle B is congruent to angle D, and angle C is congruent to angle E. That wasn't even right. E. Okay? Nope, that's not right either. That was triangle. All right. My hint in number 7 in a problem like this one. Just mark up your diagram with only the information that was given to you. Mark up your diagram with only the information that was given. So ABC is an isosceles triangle. Isosceles triangle. I can mark that. That's what isosceles triangle means. Two sides are equal. BD is perpendicular to AC. That's what this symbol means, that BD is perpendicular. And I really don't have to draw it twice. If I do it once, don't you know this other angle is also 90? Because they're a linear pair. So the first thing it says is name the theorem that could be used to determine that angle A equals angle C. What theorem do we know that tells us angle A is congruent to angle C? Base angles theorem. If you're given an isosceles triangle, the base angles theorem says the opposite angles are congruent, opposite of the same sides. So the first answer here is base angles theorem. Okay, so now I've marked my triangles up, and I'm supposed to pick from side, 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 angle, side, angle, side, angle, 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 side. What do I have? What's that? Angle, angle, side. I have two angles, and I have a side. The only two theorems with two angles and a side are angle, angle, side, and angle, side, angle. But the important thing to remember with angle, side, angle is the side has to be between the two angles that are congruent. And in this case, they are not. The sides are not between. They'd have to be here and here. Okay, so given the information that I have, not anything I'm going to assume, because I do know I could keep working on a proof here and say that BD is congruent to itself using the reflexive property. Or I could say CD is congruent to DA, because I know in isosceles triangles, the perpendicular, or the altitude that comes down, splits it in half. That's another theorem. There's several things I could do to prove this, but I'm only going to use the information that was given to me. And the only information that was given is BD is perpendicular, so I know these two angles are equal. And A and C are equal from the base angles theorem. Therefore, the only one that works is angle, angle, side. Okay. Number 8. Find the measure of angle 1. I'm told these two are parallel. That might come in handy. But first off, this first triangle is isosceles. What does that tell me about the two angles that are missing in that triangle? They're equal because of the base angles theorem. Okay, if they're equal, and the whole triangle has to be 100, added together, those two angles must equal what? 100, because we've got 80 at the vertex. So the base angles together are 100. And if they're equal, what are they equal to? 50. Okay, so this angle is 50, and this angle is 50. Now what can I do? Well, if I see that these are parallel, and there's my transversal, and this is 50, what's that angle? 50, because of the alternate interior angles theorem. That means this is 50, right? So what's angle 1? 50. Because this angle and this angle are the base angles in this triangle. That's your vertex angle. Okay, find the value of x here. Well, I'm given two angles, and I'm given it's an isosceles triangle, but these two angles are not equal based on the isosceles triangle theorem. The base angles theorem says these two angles are equal. So I know I've got 6x plus 4 plus 18x minus 8 plus this angle is also 6x plus 4. And altogether, those three angles must be 180. Right? So now I'm just going to simplify. 12 plus 18 is 30x. 4 minus 8 plus 4 is 0. X is 60. I can check it. If I put 60 in for, does that make sense? It should be 6. It's a good thing everybody's paying attention to Mrs. Reader's mistakes. 6. 6 times 6 is 36, plus 4 is 40, which means this must be 40. 18 times 6 minus 8, what do you think? 100? Okay, number 10. If ABC is isosceles, and B is the vertex angle, AB is 20x minus 2. BC, 12x plus 30. AC, 25x. Find x and the length of each side. Okay, when they tell you that B is the vertex angle, it's really important that you make it the vertex angle. Don't just draw a triangle and label it ABC and then mark it up like this, because you're going to get your sides wrong. Does that make sense? So make sure your triangle is drawn right before you start labeling the sides. Now, I know these two must be equal. Equals. (8x) equals 32. So x is now 4. So I found x, which was the first thing. Now I'm just going to plug it in and find the length of the sides. 4 times 20 80 minus 2, 78. This should be 78 if I did my math right. So 12 times 4 is 48 plus 30, 78. And 25 times 4 is 100. So the lengths of the sides were 78, 78, and 100. Questions on that? Important part here was getting your triangle drawn right and understanding what, when they say the angle is the vertex angle in an isosceles triangle, that's always the one on top. All right. Use the figure below to answer the following questions. Find the value of x. So what can I do with these two? Yeah, add them up and set them equal to 180 because they make a linear pair. Good. $11x minus 40 equals 180. 1 and 220. So I found x. X is 20. X is 20. So what is this angle? 3 times 20 is 60 minus 5. So this must be 130. 8 times 20 is 160 minus 30, 130. Okay, find angle 1 if angle 1 is 4x plus 10. Well, what did we say x was? 20. So 4 times 20 is 80 plus 10 is 90. Now find angle 2. Yeah, this is 140, so this must be 40. What's one final thing I could do to check that? What's the exterior angles theorem say? Yeah, the exterior angle of a triangle must equal the sum of the interior angles. And it does. All right, in the figure, AC is congruent to FD. Mark up your test. Mark up your drawing so that you can visualize what this is. AC is congruent to FD. AB and DE, AB and DE are parallel. AC and FD are parallel. Determine which postulate can be used to prove the two triangles are congruent. Choose from side, 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 angle, side, angle, side, angle, 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 side. Okay. What do I know about this angle as it relates to the other triangle? And if it helps, go ahead and draw these two parallel lines with this as your transversal. Parallel, transversal. I'm looking for this angle. What's it congruent to on the other triangle? Right here, right? So those two are congruent. What else do we know? Well, we have another set of parallel lines, these two. So if I draw those two, and this is my transversal, what do I know about this angle? And where am I at? Parallel. This angle, and this angle. Those are congruent too, right? Alternate interior. So now I've marked it up. I have angle, I have an angle there, and I have a side here. So what postulate am I going to use? If it helps, break them up. This is A, I'm going to call A, B, C, D, E, F, just doing them in the right order. Angle C and angle F are congruent. FD and AC are congruent. And angle B and angle E are congruent. Just putting them side by side? Well, what has to be true with angle, side angle? Has to be in consecutive order. So this angle would have to equal that angle for angle, side angle to work. Or this side would have to equal that side. I don't have either of those. But I do have two angles. So there's one more that has two angles in it. Angle, angle, side. Yep. Angle, angle, side. So first off, don't tell me it's side, 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 or side, angle, side, because that requires two sides, and I'm not given two sides. Use exactly the information given. And if it helps you to break up the triangles so it's not looking so confusing, then do that so you can see it. Okay? All right, complete this proof. ABC is an isosceles triangle with base AC. I know that's, mark it up as you go. D is the midpoint. That tells me that this is equal to that. Prove that BD bisects ABC. So I need to prove angle 1 and angle 2 are congruent. That is my goal in this proof, to prove those two angles are congruent. So the first thing on the proof is they rewrite the given. And I'm going to mark this up. And I need to A, B, C, D. Now I've forgotten. A, B, C, D. Okay, they tell me this is the midpoint, so I can say this, but I'll have to prove it in the proof. So they say that AB is congruent to CB, definition of isosceles triangle. That's true. Angle A is congruent to angle C. Why? Base angles theorem. Good job. D is the midpoint given. AD is congruent to DC or CD, midpoint theorem. Now they're saying that ABD is congruent to CBD. So I've proven this. If I'm trying to prove two triangles are congruent, your answer should be one of 5. What are they? Hypotenuse leg. Has to be a right triangle. And this is not. It is, but they didn't give us that. So we're not working with a right triangle. So based on only the information I've drawn on my sketch, which of those 5 theorems can I use to prove these two triangles are congruent? Side, angle, side. This is why it's really important to mark up your triangles so you can see it. Ultimately, I was told to prove angle 1 and angle 2 are congruent. So once I've proven the triangles are congruent, I can say 1 and 2 are congruent because corresponding parts of congruent triangles are congruent, CP, CTC. Okay? All right. I did both of those. So here's the bonus. In the figure, ABC is isosceles, ADC is equilateral, AEC is isosceles, and the measures of 9, 1, and 3 are all equal. Find the measures of the 9 missing angles. This is a puzzle. So what do I know about 3 and 4? Angles 3 and 4. What do they tell me about triangle AEC? Isosceles. So that means 3 and 4 are equal. What do I know? Let's see. ADC is equilateral. So I know that angle 2 plus angle 3 is equal to angle 4 plus angle 5 is equal to angle 8. Right? This angle and this angle and this angle, which is equal to what? What are each of those angles equal to? Measure. Yeah, because they're all three the same angle, right? And there's three of them, so 60 degrees. So I've already found angle 8. I know angle 8 is 60. So I know angle 2 plus 3 equals 60, and I know angle 4 plus 5 equals 60. This is 3. Okay, what else? I know 1 plus 2 plus 3 is equal to 4 plus 5 plus 6, because this long triangle is isosceles too. So what does that tell me about angle 3 and angle 6? If 2 plus 3 equals 4 plus 5, 2 plus 3 equals 4 plus 5, don't 1 and 6 have to be equal to? So I know angle 1 equals angle 6. What else? There's got to be some substitution I can do now. What else do I know? Well, if 4 plus 5 is 60, so these are both 60. 1, 6, and 9 are what's left on the long triangle. Right? 3 and 4 are equal. So what does it tell us about 2 and 5? They're equal. And I know 3 and 4 are equal. What else am I missing? I've got 8. I'm missing 7 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Is there any other piece of information that would be helpful? What else did they give us up here? The measures of angle 9, 1, and 3 are all equal. Let me do it this way. Angles 9, 1, and 3 are all equal. Well, if I start here and look at the long triangle, I know angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 9 equals 180, right? And I know that 9, 1, and 3 are equal. So let's just call that x, x, x. And I know that 3 and 4 are equal. So 3 is x, 4 must be x. I know 1 is equal to 6, so that's x. Do I know anything special about the relationship of 2 and 5? Well, 1 and 6 are equal. 3 and 4 are equal. What about 2 and 5? Two and 5 are equal, but how are they related? Well, we know 2 plus 3 is equal to 60. We know 4 plus 5 is equal to 60. So if I'm going to call 3 x, I could say 2 plus 3, 2 plus x is 60. Or sorry, angle 2. So angle 2 is equal to 60 minus x. And angle 5 must be 60 minus x because those two are equal. Now I've got everything in terms of the variable x. So I have those cancel 1, 2, those cancel 3x plus 120 equals 180. 3x equals 60, so I know that x is 20. That means angle 1 is 20, angle 3 is 20, angle 4 is 20, angle 6 is 20, angle 9 is 20. And that means that 2 and 5 must be 60 minus 20, or 40. And I found 8 to be 60 right off the bat. There you go. It's just more substituting with what you had. But you can watch the video again if you want and see if you can follow it the second time. All right, test is tomorrow. No school on Friday.